Welcome to this Ivory 8 presentation, Connecting KNX and Control 4. For many years, it's been possible to link KNX and Control 4, enabling two-way communication between these two systems, which enhances many areas of audiovisual and building control in these projects. Historically, KNX and Control 4 systems were linked together with a KNX IP tunneling connection using a KNX IP interface. The Control 4 driver used for this older method is the KNX network driver, which we can see here highlighted with the red box. In this case, the C4 controller running director is acting as a regular IP device. And the C4 controller communicates only with the KNX IP interface, and the C4 controller does not form part of the KNX installation. There are some problems related to this method. So historically, there were some compatibility issues between certain KNX IP interfaces and Control 4. Periodically, tunneling connections will disconnect when they're idle. It's normal, but with this use of tunneling, it can cause loss of telegrams. Furthermore, it's only possible to connect Control 4 to one KNX twisted pair bus line using the C4 KNX network driver and a KNX IP interface. And lastly, but not least, the KNX twisted pair bus communicates at a very low speed, 9,600 bits per second, which corresponds to a maximum of around 50 telegrams per second. So as we can see from this indication from ETS here, if we take the last couple of points into account, for a KNX installation where there's more than one twisted pair line, there will necessarily be additional traffic passed on to the higher line so that the commands and feedback can be transferred between KNX and Control 4. So here we have several lines here. The traffic from these lines would need to be passed up onto the main line in order to be reached by Control 4. And the problem is, with the low communication speed of twisted pair, it can cause bottlenecks and potentially loss of telegrams. So there is a better way. Since Control 4 began marketing their own KNX devices, they released the KNX routing gateway driver, which again we can see here highlighted on the right. This is now the only recommended way of connecting KNX and Control 4, and it uses a KNX IP multicast connection and makes use of KNX IP routers rather than KNX IP interface. In this case, the Control 4 controller that's running director is a KNX Net IP device itself. It takes a KNX individual address and is part of the KNX installation. So advantages of this method. Firstly, multicast is always on. Multicast doesn't periodically drop the connection when there's no communication, when communication is idle. Also, using KNX IP routers, we can connect multiple KNX twisted pair lines simultaneously to Control 4 using that KNX multicast IP address. And last, again, but by no means least, the KNX IP communication is several orders of magnitude faster at either 10 megabits or 100 megabits per second, depending on which KNX IP router you're using and the rest of your IP network. So taking the last couple of points into account, for a KNX installation with multiple twisted pair lines, there are not any higher twisted pair lines above the sublines. Everything above that is IP. And commands and feedback telegrams are transferred between KNX and Control 4 over KNX IP at high speed. They're only retransmitted on twisted pair lines where the telegrams are relevant. And so this eliminates bottlenecks from the buildup of bus traffic on the higher TP lines. From the graphic here, we can see we've got the sublines, which are twisted pair, and those IP routers communicate onto the multicast backbone above, and that's where our Control 4 controller is located. So there are some considerations that we have to make regarding the way that KNX telegrams are normally filtered across different parts of the topology. In this first scenario, if we consider a KNX IP routing situation with a single twisted pair line, we can actually set the IP router to route telegrams in both directions. We only have one line, so all of the traffic that's on the TP line is going to be passed up into the IP main line where Control 4 is located. And any telegrams coming from Control 4 for commands, let's say, they will be passed straight down into the twisted pair line. So the communication between those sides is unhindered. All the traffic goes in both directions. The alternative is where we have several twisted pair lines. So here we've got three that you could have, tens or potentially even up to a couple of hundred sublines. In this scenario, we don't want all of the traffic that is happening, that is going on in the IP mainline or the IP backbone being routed to all of the twisted pair lines, because then things would get overloaded on the twisted pair side. So where we have this kind of situation, we either require to enter manual filter table entries for each IP router. That could be quite time consuming if you had a lot of lines and a lot of group addresses. Or we can make use of a dummy device. So a dummy device here gets added to an ETS project, and it represents a KNX, generally a KNX server, which itself is not configured within ETS. So until recently, a dummy device configuration could be quite time consuming. However, we now have a new option from GIRA. So GIRA's new dummy device secure makes configuration of filter tables very quick. Here I have some group addresses which are linked to KNX actuators, and Control 4 needs to be able to control and receive feedback using these group addresses. So what I've done here is I've taken the middle groups, you can see highlighted in blue, and you could even do it with the main group actually, and you drag either the middle groups or the main groups or even individual group addresses up to the dummy device, which we can see in the top panel there, and it just shows link with. And by that method, you can link many group addresses very quickly to the dummy. And here we can see that all of those group addresses are now linked with the dummy, which is in the IP mainline 1.0. And once that's happened, ETS will automatically add the group addresses to the filter table of each applicable IP router in the twisted pair sublines 1.1, 1.2, and 1.3. After those IP routers are downloaded, telegrams with the group addresses which originate in all three of the twisted pair lines will be routed onto the IP mainline, where Control 4 can receive those telegrams. Conversely, telegrams which are originating from Control 4 in the IP mainline will be routed only onto the relevant twisted pair line, which reduces traffic on the twisted pair bus. Here are three IP routers that are frequently used in projects by our customers. These come from our manufacturers ABB, GIRA, and Vinciril. Each of them has features that may make them particularly suitable for your own projects. There are links to these products in the video description. Please contact your local Ivory Egg account manager for more information. So thanks very much for listening, and I look forward to seeing you again very soon.